Okay, we have just finished our midterm examination, and we will review what you did for the half of our semester, and we will continue the last half part of linear algebra. Okay, so I have uploaded the lectures here for chapter 7 and chapter 8, chapter 7 and 8 and 9 and 10. I will continuously update it, and I have made what notice. Okay, here. I have I gave you the format of the midterm examination which you took, and most of you did very well. And I have uploaded the solutions for your midterm examination. So if you find anything you don't understand or misprint, then let me know. I will fix it. And I gave you true-false problems, many, and I asked you to write 5 definitions among these 8, and I asked you to find or explain some computational problems by hand, and I asked you your knowledge on computational skills on dealing with linear algebra problems in Raji, and I asked you the concept and the meaning of the command and the output. And also, I asked you to explain or prove or give a sketch of the proofs for some conceptual problems. And also, as I mentioned earlier, I counted your participation as a point. Okay, if you have any questions, and you are free to ask me anytime in a week. And I asked you to write your after note for your midterm examination, and I asked you to read the chapter 7 before you come to class and ask or leave your answers on the questions. And also, I supplied the information on the chapter 7 that I made for you, which we will cover. So we will discuss a lot from here. We will use 2 weeks for this chapter 7. Okay, so we start from the definition of basis and dimensions, and then we will use those concepts for the most important of knowledges on linear algebra. And I also gave you a Korean version of lecture note here. Here you will find the very easy explanations of the concepts and the examples and theorems and proofs and the code and the output on chapter 7 in here. It's only 2 pages, so you will go through it easily. And actually, I gave my lecture on this for Korea National Open University students, and still it is a part of online course for those students at Korea National Open University. And this is a chapter 7 in here. This is chapter 7. Yes, this is what you supposed to see. Actually, these you can find all the chapters here, up to the chapter 7 and chapter 10. And also, though you can find these the basis and dimensions and properties and the dimension theorem and length theorem and projection theorem and least square solution and QR factorization and Gram-Schmidt social normalization process, and also coordinate vectors in here. I also gave you this. Actually, I made this about 10 years ago, more than 10 years ago, and And you will see the sound. Yeah, this is very old version, but it will be pretty interesting to see. Yeah, it is what? It is well made, actually. It was used for the Open Cyber University before. And I also gave you the solutions for chapter 7 here. So, for example, you will see the problems and solutions, and also as well as the code. So, if you read the textbook, then you will easily follow the problems and solutions in here. Okay, and most of you did the homework before you come to class. So, yeah, those who leave the comment and questions or answers in Q&A will be counted as your participation. For the midterm examination, the best score was 96 out of 100, and there was 4 students whose score was above 90. They are all A's. And I also urge the freshman student to get a good grade. Average of the class was 73, and you did, most of you did well. And I found that most of you understand what we have covered. And also, for those who have something to say to me on the exams and the bonus credit, and come to my office at 3 p.m., then I will check on you. And we will meet in this new classroom, which is better equipped. The room number is 332 356A here from the next week. And also, we will really cover the contents of linear algebra in a flipped learning and self-oriented lectures. Okay. And next Tuesday, we will meet here like today, and we will really cover the contents. Next Thursday is Children's Day, which is a holiday, so we will cover in order to cover the chapter 7, we will use this iCampus system more to cover the chapter 7 in 2 weeks. And also, this is a paper that was recently published, the February of this year, and this is a kind of report for the flipped learning class of linear algebra. And here you will find the web addresses and what we have done over the last semester, and what you will see. You will understand what I intended for the lectures in this semester. Here, so you go through it, and you will see what we intended by this flipped learning class of linear algebra. Okay, and as I mentioned, you leave your afternote for the midterm examination, and you made the questions. And Mr. Itaehi, and I gave an answer here. And here, if bx is equal to 0, then clearly when you applied A, it's just the product of the matrix A on a 0 vector, so it should be a 0, which means X is a solution for this is in the solution space of AB. So any vectors in here is the element in the solution space of this. That means null space of B is just null space of AB. It's a subset of a null space of AB. So that's what it meant. Okay. And what? Mr. Park Jong-woo, and you asked you made a question on these inequalities here. Your question was, if we have some information on these two, one of these or both, then clearly, yeah, we can tell some properties of this length of AB. But without it, it doesn't, except that it doesn't much. Okay, here, and Gaussian elimination, yeah, the geometric meaning of Gaussian elimination here, and as I mentioned, your sense of geometric meaning is in dimension 2 or 3, but the subject that we are dealing with are the n-dimensional vectors and matrices and functions. In n-dimensional spaces, is a geometric meaning in 2 or 3-dimensional spaces doesn't have a big meaning. So we should find the other way to approach it, to have a real meaning of those mathematics. So in here, yeah, we better use the definition of dimension or length to understand how these n-dimensional vectors works in n-dimensional vector spaces. So I recommend you to take a look on these 4 fundamental subspaces theorems and things like this. Yeah, you will find, this is what we're going to cover in chapter 7. Okay? And Mr. Park Jong-woo, and you also asked some questions here. And my answer is this. Every m by n matrices are, the set of all m by n matrices is itself a vector space. Actually, it's a subspace of the bigger one. And every m by n matrix is a linear transformation. And yeah, this question was wrongly presented. And yeah, for this, I can tell that there's no specific relations. And matrix and vectors, yeah, inner product for the matrix, yeah, sure. Yeah, similar method, similar definition worked for matrix instead of vectors, which will be covered in chapter 9. Okay. And what else? Yeah, and also, yeah, many of, yeah, each of you made the after note, such as, yeah, orthogonality, yeah, here, yeah. Mr. He asked the question that the orthogonality for n-dimensional vectors or matrices and the continuous functions also can be defined by using the general definition of inner product, which will be covered in chapter 9. And Mr. Kang San and Park Jong-woo and Kang Seop, yeah, they found something. Here I may add. Yeah, each of you, yeah, gave a presentation of the problems in at least one chapter, and you solved most of the problems and you made even presentation. But the problems that you made still had the minor problems, minor the faults in it. So yeah, I found, you need to learn a little more to be precisely present your new problems. And and these are the things that you mentioned. Okay, I asked you. So, yeah, good. Yeah, most of you made it. And also, Mr. Oh Chung-han answers that the null space is a solution set of this linear system, homogeneous linear system of equations. And the null space is defined for a matrix A instead of this homogeneous system of linear equations. But eventually, those are same subspace in Rn. So yeah, we can tell that dimension of a null space and the dimension of a solution space is also same. I think that's it. And also for the van der Monde matrix, yes, yeah, the van der Monde matrix was used for the interpolation problems, and I gave some information for the interpolation that makes that, which means you can find the polynomial that passes through the point of yours. And there are several techniques that can improve those. And least square solution can be also used. And cubic splines, and those are the things that you will learn in optimization class or linear programming classes in industrial engineering department. Okay, and I think that's it. Okay, any questions before on those before we cover chapter 7 here? Chapter 7. Any questions? Okay, yeah, we have covered chapter 1, 2, 3, 4, and 6, and now we will start chapter 7. In here, in this web address, which I have recently developed, I have uploaded my lecture note here, and also my lectures can be viewed not only by you, but also by all other students in our university, and also other students in whole world. And we have covered up to chapter 6, and your presentation of the solutions of the problems up to chapter 6 was also viewed here. And as you see, this recording was a little bit here. The recording had minor problems like this, so that's why I changed the educational environment because of this. Okay, anyway, here. And also, there are. I'm also teaching another course here. You will find some more, graduate level linear algebra on LU decomposition and Schur decomposition and power method and QR decomposition, which is one section in chapter 7, and singular value decomposition and least square solutions. And these are the things that actually you have to know in order to use the linear algebra knowledges in real life problems. Okay, I think now we are ready to cover chapter 7. Any questions?